Welcome back to Destin Learning. Today, we're diving into a foundational concept of Python programming, modules and imports. Python modules allow you to organize your code into reusable and manageable components. With modules, you can leverage Python's extensive standard library or create your own reusable code files. By using the import statement, you can bring in powerful tools, libraries, and functionality into your projects, saving time and effort. In this session, we'll explore how to create and use modules, import functionality from Python's library or custom files, and make your programs more efficient and modular. Let's get started and unlock the true potential of Python modules. In Python, a module is a file with reusable code, including functions, classes, and variables. Modules help structure code logically, making large applications more organized, maintainable, and scalable. Python offers built-in modules such as math, OS, and random. You can also create custom modules. Additionally, third-party modules are available via package managers like pip. This guide covers the basics of modules, including their definition, how to use them with imports, and their advantages. Detailed examples are provided to illustrate these points. A Python module is a .py file containing code. It can include functions, classes, variables, and other executable logic. Modular programming in Python offers several benefits including code reusability, better organization, easier collaboration, reduced redundancy, scalability, and access to built-in libraries. Python allows importing modules in three ways: importing the entire module, importing specific components, and importing with an alias. Each method has its syntax and use cases. Here is an example of how to import a built-in module. In this case, it is the math module. The random module offers functions to generate random numbers. To import a custom module in another file, follow the necessary steps to ensure proper integration. To create a Python module, name the file mymodule.py and add the necessary content. Modules can have test code that runs only when executed directly, not when imported. A package is a collection of modules organized into directories within a init.py file. This structure allows for better organization of modules. Here is an example of how to use the package. Python supports many third-party modules that can be installed using pip. For example, the request module can be installed and used in Python scripts. To manage modules effectively, use clear names, avoid circular imports, keep modules small, and use aliases wisely. Python modules help in organizing, reusing, and sharing code efficiently. They make code more maintainable and scalable. Python offers built-in modules and supports custom and third-party modules for extensive functionality. In summary, understanding Python modules is crucial for importing libraries, creating custom modules, and using third-party packages. Mastering them leads to cleaner, efficient, and reusable code. That's all for our session on understanding Python modules and imports. Today, we explored how modules help you organize code into reusable components and how to use the import statement to leverage Python's powerful libraries or your own custom modules. With these tools, you can write cleaner, more efficient, and modular code. Thank you for joining us at Destin Learning. If you enjoyed this lesson, don't forget to like this video and subscribe to our channel for more programming tutorials. Keep practicing, stay curious, and we'll see you in the next session. Happy coding! Bye-bye.